So today we're going to talk to you about Group 11, which is also known as the Coinage metals. We're going to go over copper, silver, and gold, and this is presented to you by Sarisha Jokipati, Ryan Joy, and Candace Stroud. To start off today, we're going to go into a little more detail about why these were called coinage metals. Historically, they were named so because of their purpose, but we'll go into the details of the 4 reasons why they were so optimal for this use. So the 4 reasons why these are called coinage metals include the fact that they are easily found in a metallic state, they're ductile and malleable, they're quite unreactive chemically, and Ag and Au are known to have intrinsic value.
We're going to start with why they're found in the metallic state. First, there are not enough electrons on a metal atom to allow it to fill its valence shell by sharing pairs of electrons with 1 or 2 nearest neighbors. The only way a metal can obtain the equivalent of a filled valence shell is by allowing these electrons to be shared by a number of neighboring metal atoms. This is possible only if a large number of metal atoms can be close together. Metals are therefore solid at room temperature.
The next reason is ductility and malleability. The metal is ductile. If the metal is ductile, it means that it can be drawn out into a wire, and whenever it's malleable, it means that it can be bent. The reason why metals can do this is because most metals are in body center cubic, hexagonal closest packed, and cubic closest packed formations. Within these formations, if a lot of force is put on this lattice, the atoms can move within a single plane. Because of these properties, the coinage metals were used because they are easily worked with.
The next property we're going to talk about is the unreactivity chemically of these metals. So we're going to look at the reactivity series. That is a chart that scientists came up with to describe the reactivity of the common elements from most reactive to unreactive, and copper, silver, and gold are actually found at the very bottom of this reactivity series. This means that the metals are not easily oxidized to form positive ions, therefore attacked by most reagents such as oxygen or acids is slow. This resistance increases from copper to gold. Conversely, the reduction of their compounds to the pure metal is easiest for gold and reduces through silver to copper. Because of this resistance to chemical attack, the metals are unreactive, including to atmospheric components such as oxygen and water.
The last reason that these are called the coinage metals is because of the intrinsic value that is associated with these metals. They are so highly valued because of the rarity of them found in nature.
Next, we're going to talk about why they are the color they are. First off, copper is one of 2 common yellow metals. This results from the visible region electron absorption from the D band to the SP band. Copper often looks reddish because of the thin layer of copper oxide.
Gold's color is formed a little differently than copper's. Because gold is such a heavy metal, there's relativistic effects within gold, and this means that the electrons within the s orbital are moving at such a fast rate that the mass is increasing and the size of the electrons are decreasing. Because of this, the SP bands and the D band become closer together, which allows for an absorption to be in the visible spectrum and a production of the yellow light that you see.
So for silver, unlike gold, there's less relativistic effects, which results in a larger separation between the SP and D bands. This causes absorption in the ultraviolet region of the spectrum, which produces a grayish sheen color.
Now we're going to discuss how each element is extracted. First off, copper is extracted by using a thermal process or an aqueous process. Due to time, I will only discuss the thermal process. In this first reaction, the mixed sulfide is decomposed to give an iron 3 oxide and copper 1 sulfate. Sand is then added to the molten mixture, which converts the iron 3 oxide to a slag of iron 3 silicate. The liquid floats on the surface and can be poured off. Air is added again, which causes the sulfide to be oxidized to sulfur dioxide. Copper 1 sulfide is converted to copper 1 oxide. After 2/3 of the copper 1 sulfide is oxidized, the air supply is discontinued. The mixture of copper 1 dioxide and copper 1 sulfide then undergoes an unusual redox reaction. This gives an impure copper metal.
Now for the extraction of gold and silver, they both go under the same processes. I'm going to talk about silver. There's a few methods. One method of extraction of the metal involves the treatment of pulverized silver 1 sulfide with an aerated solution of sodium cyanide, a process that extracts the silver as the dicyanoarginate 1 ion, as you can see here. From there, an addition of metal zinc causes a single replacement reaction in which the very stable tetracyanozincate ion is formed, as you can see here. The pure metal is obtained by electrolysis using an electrolyte of acidified silver nitrate solution with the impure silver as the anode and the strip of pure silver as the cathode. And this is that process.
Now we'll discuss an interesting fact about each. Pure copper has the highest thermal conductivity of all metals. This is why it is used in premium cookware so that the heat is distributed rapidly throughout the walls of the container.
Historically, silver was used to purify water. Nowadays, it's used more commonly with silver nitrate to prevent infections in babies' eyes. Other applications of nanosilver in present day include using it as a coating for many household items. Examples include kitchenware, air filters, cleaning products, and toothbrushes.
An interesting fact about gold is its use in medicine. Whenever it's used in medicine, it's called chrysotherapy, and it is mainly used for rheumatoid arthritis patients for reducing inflammation.
So in conclusion, there are 4 reasons why these are called coinage metals, including the fact that they're found in the metallic state, they're ductile and malleable, they're quite unreactive chemically, and their rarity causes them to have intrinsic value. Additionally, each of them exhibit different colors based on their varying atomic chemistry. As far as the extraction for each of these elements, copper uses heat with oxygen as well as sand, whereas silver and gold both use cyanide and then metallic zinc. Also, all of these have very interesting applications, a few more of which you can see following this.